Hello, this is Dr. Oz. In this video, I would like to briefly talk about data cleansing and handling missing data problem. And I'm not going to go so much into details of this, but this is one of the most important issues in real world because the data is never going to be clean. There will be always issues. There will be some missing data. There will be some wrong data, and so on. I would like to show you an example of tire company. All right, so data cleansing, there are two different types of missing data. One, legitimately missing data, and this naturally occur, and this doesn't create really bias problems. Like, for example, fail to record data, or unintentionally making something wrong in the data, or the machine fails randomly. So this is legitimately missing data, and in this case we don't need to do any action really because this is legitimate. However, sometimes data is missing illegitimately, and if that's the case, then we gotta make sure that we take an action, and one of those actions is that discard observations. In other words, discard your rows. Another could be discard your variables. Discard any variable. So these are discard your column. Or another approach is fill in missing entries. Fill in missing entries, right? Again, we gotta be careful about doing any of these, and you need to go through a thorough analysis. And we could use data mining algorithm. Data mining algorithm to handle that missing data. So if missing data is completely at random, MCAR, that means that the data missing really does not depend on either the value or value of the missing data or value of any other variable. So what do I mean by that? So for example, maybe you are having a survey and you realize that fat people do not disclose their weight. So now that is not missing completely at random, because you know that the value of their weight is so high, and that's why they are not reporting it. Okay, so this can create a bias problem in my research. Another thing could be maybe whenever people are, let's say, conducting research, given alcohol consumption, and after they drink couple beverages, alcoholic beverages, they may start reporting things, let's say sexual misconduct, that they would never ever do it without alcohol consumption. I'm just giving an example. So this is not a random situation, because I know that alcohol consumption makes them disclose certain things, or in other cases, if they don't consume that, they will not really disclose the same information. If I put this same thing, same observations in my same data set, that's not missing completely at random, and I need to take an action on that data, otherwise I will get wrong results. Another type of missing data is missing at random, MAR. In this case, the tendency for an observation missing a value for some variables related to value of some other variables. Again, alcohol consumption was an example of this. Missing not at the random, the tendency of variable missing with blah blah. So this is like more like again, weight problem example. And imputation is called replacing these values systematically, reasonably, scientifically. Okay. So let's take a look at auto sales, auto tires, and this company, U.S. company, Blakely, They basically obtain data of the position of the tire of the automobile and age of the tire, mileage, and depth of the remaining tread. And they are trying to assess their quality. So let's take a look at our Excel file, tread wear data, and see what's going on. All right. So, okay. So here you can see the data in the Excel file. I have 1, 2, 3, 4, 5 columns. Let me just highlight them. Control B to bold it. Let's center aligned. All right. So this is my data file. Maybe I would like to color code green, and I don't like to have, let's say, this much height for this title. So what I'm gonna do is just expand these a little bit, and maybe I will just abbreviate my data a little bit so that I don't waste space. Okay, I delete this and make it ID. I will make this one auto instead of automobile, so that it will give me some space. Let me just make this wider, a little bit more, a little bit more. All right, let's make this one wider. Top left corner, double click, double click. All right, so this is my data. Looks like I have ID numbers for each tire. I have the position in the car, left, rear, I guess, rear, right rear, left rear, left front. Where's my right front example? Right front. All right, so there are 4 tires obvious in a car. LR, left rear, RR, right rear, LF, left front, and RF is right front. All right, so you can see the life of these tires in months and tread depth, and in the United States, there's a regulation for this industry that has to be between 2 to 10 of an inch. So if something is less than 2, it's no good. If it's more than 10, which kind of doesn't make any sense. And we see the miles for each of these. So I like to see my numbers in a certain format. So I will Control Shift down, click on this comma to make these numbers comma style to make it more readable. And I would like to eliminate my decimals, decrease decimal. All right, so this is my data. Now I would like to calculate some things. I will call this section model. All right. So in this model section, excuse me. Values. All right. So I will calculate the missing values for each of my variable columns. In this case, I have life of tire and my variables. I could have it for position of the 8 auto as well. Let me just look at how many data points do I have. The count here is 456 tires. All right. Obviously 456 can be divided by 4. That's a good news. And here I have column B, I have 456 observations too. That's good. So let's calculate our missing data for these 3 columns. All right, so to be able to calculate the missing data, I will use count blank. Count blank function, and my range is here. And I will drag that right. So it looks like I don't have any missing data in these 2 columns, so I have missing data in miles column. What if I use count A? Let's see what that would give me. Counts the number of cells in a range that are not empty. That's another way to do it, right? All right, I have 456 observations, but here I have 455. Count A also tells you whether you are missing data or not. All right, we use count blank. So what I'm gonna do is now sort my data based on miles. Okay, so let's highlight this area, Control Shift down, data, and sort based on miles. Let's go smallest to largest. And when you do this and you scroll down, you will see that you have one missing data here. Let me just color differently. So this is your missing data. All right. So what's going on here, right? That's an important thing to figure out. So why this is missing mile data, okay? Before doing that though, I thought I'd change my number format for all my data points. It looks like I didn't. Let me just highlight again my miles column, right? And then make them numbers and eliminate decimals. So again, when I look at this data, missing data at the end, here is my problem, right? This tire ID is the problem. So if I just copy that and I color code that too. Now let's resort this to see what's going on with that car. All right. Highlight my data and then data sort. This time let's sort based on the ID number, smallest to largest. And now let's go Control F to search for the ID number that we identified and find all. And looks like there are 4 of them. That's great because one car has 4 tires, obviously. And they are right here, right? So these are my 4 tires. So let's see what's going on. Right, left, that's good. Front, rear, front. That's good. But here the mileage information is, you see, this is the missing data. So here I think this is a reasonable situation for me to think that this data is not, there is no illegitimate missing data, because I have 456 observations and only one of them is missing. I don't think that's because of the value of that or any other variable in data set. So I can assume that this data is same as the other 3 tires. Again, maybe not, because maybe that person changed only one tire, not all the tires at the same time, and that tire is maybe newer or older. But I think assuming that this tire is same as others is not going to change my model so much, because one, I'm only missing one observation of 456. 2, I see that other observations are similar. So I don't see why not to handle this by assuming that this is exactly the same mileage. Okay, so that's one thing. So if I look at the mileage information here, and maybe what I would like to do is, so we basically handle this missing data problem, right? I had 1, now I don't have any. So what I would like to do is, now I would like to look at the life of the months, life of tire in months. Let's sort this based on life, smallest to largest. So when you look at the life, you will see that, I mean, life of this could be 1-2 months. That's okay, right? I mean, that's not something red flag for me. But when I go crazy like this, 600, 111, that's a red flag for me, because these values, I think, are extremely high in comparison to other values in this model. Again, I cannot right off the bat say, hey, this is wrong. or there's a problem here in this data, but it shows me something that's going on, right? These two. So let's see what's going on. I will copy these, Control C. Okay. And I will handle that. And I would like to look at 212, 21, 22 as well, all right? So what I'm gonna do is sort my data again based on ID. Data, sort, based on ID, smallest to largest, click OK. Let me search for the data that I was looking for, Control F, Control V, find all. Looks like I have 4 tires again, perfect. Let's see what's going on here. All right, so these are my values. Okay, so now this is telling me a story, right? These are the same same car, but all 3 tires, other 3 tires are 60.1 months, and this is 601. So probably what's going on here is that there's a typo, right? Instead of typing 60.1, they type 601. So I can handle this data by issue by this too. Another data that was kind of high was 21, 22, starting with that. And here it is, right? So if I look at these 4 tires from the same car, you see that again, the other 3 tires are 11.1 and this one is 111. So let's handle that too. All right. So these are some things that you can fix like this. But again, you got to be very careful while you are doing this. So if I now do the same thing for the thread depth, let me just first do view freeze so that I can see these headings easier. All right, so what I'm gonna do is sort this data again based on this time thread depth. Data sort thread depth, smallest to largest. Okay, I start seeing again some issues here, right? We say that it should be minimum 2, but I see some observations that are less than 2.2 inches. So these values could be a problem, right? Or not, I don't know. And if I go down all the way, because again, we were talking about this is an insanely big number. The car should not be driven by flat tires, 0 tread, or our threshold was 10. But again, even if I assume that there's some people waiting longer than 10, 10.9 and so normal, I don't think this is normal. All right. So this is way too depth is so big. So this means that the car tire is very, very high in depth. So again, is this something that's a problem in terms of data? Probably, but maybe there's something going on. Maybe there's a special tire that this guy put. I don't know. So it's kind of it's impossible pretty much to know all these things as a data analyst. But this is a suspicious situation as well. An outlier. And if I do the same thing with miles, again, data sort based on miles, smallest to largest, and you see that low miles possible. Maybe these cars are new, but these tires are new. But when you go down, you start seeing crazy numbers, right? Maybe these are outliers that doesn't make any sense. I don't know. Maybe there's a data entry problem, or we don't know, right? So these are some kind of outliers. So what do we do when we have crazy numbers, right? So that we can either delete that row if we think that the tire is an accidentally entered or there's something wrong with that data observation, or we can delete the column sometimes, and we lose so much data. It's not really the ideal case, but let's say if the miles are always recorded horrible and wrong and missing data is so much, we may just get rid of this column to protect the rest of the data. Or we can replace those values the way we did with some logic makes sense. We could take average, we could look at the similar products and so on, right? Or we could use a data mining algorithm to find best value that could fit with our data. But these are all, we gotta be careful about them. But when you look at the miles, again, high values, that can be a concern too. So let me just insert a scatter plot here to see what's going on visually in this data. Insert scatter plot. And I'll right click on the scatter plot and let's select my data. Let's say, and I will add my data. My data name is tires, and x-axis values is, let's say I put tread depth. Control Shift down, enter. Say my y values are my miles. Control Shift down. Oh. All right, enter. Click OK. So now you can see the scatter plot for this data. And if you look at the scatter plot, let me just add the axis titles first. Y-axis here is miles. X-axis here is tread depth. So here, what you see is maybe I should say here, 1/10 of an inch. All right. So what I'm gonna do is look at this. So it looks like this is an outlier, right? It looks way too different than the rest of the group. This looks like an outlier. This looks like an outlier. So what we do is we use some kind of we calculate box plots, or we calculate standard deviations and z-scores, whatever statistical approach you are using. But we are trying to identify the outliers. In this case, these values, the blue ones circled, they're probably outliers, and the red ones are probably not outliers. So you may conduct your research based on all the data, and you also can conduct research based on just the data that's not outliers in the red circle, and see whether your results do change a lot. If your results do change a lot, you better dig into that research, that those outliers a lot. Otherwise, you may just say, hey, whatever, it doesn't really make any difference. So that's it for this video. Until next video, enjoy business analytics.